You must have this formula at your tip if you are a JAMB or UTME candidate. So before we go into that, don't forget to subscribe and like this video. Now look at this is what we have as wave. Wave general equation of motion, we have to state it out, is given by a y equals to a sine, a bracket, you have something that look like this, a w and a t, minusing a k and then an x. All right, or we can cream this ladder, not now, we put it as something in this form. All right, now look at what we know that. We know that y here is going to be equals to the vertical displacement. All right, vertical displacement. We also know that a is going to be equals to the amplitude. We also know that w here, which is going to be equal to the angular velocity. We also notice that t here is going to be equal to what? Time. Now these formulas we have here, or this parameter in this general equation of wave motion, have their separate formula each. For example, let's go to angular velocity, which is represented as w. Angular velocity is known to be equals to 2 pi f. Now in this case, f is involved. F also have its own formula, whereby we have that v is equals to f multiplied by lambda. If you're looking for the formula of f, you divide by lambda, cancel out. You find out that f will be equals to v over lambda. Hence, we have to replace that value for f here. Again, if you remember that f is also known to be equals to 1 over the period. All right, so these are the two formula for frequency, which is what? The f. All right, so what are we going to do? We are going to substitute that value of f, which is what? V over lambda. Substituting here, we are going to have this furthermore be equals to 2 pi. Now it is not going to be f again, it's going to be what? V over lambda. A formula has been formed. This is angular velocity is also equals to 2 pi. Now instead of f, we take this one, that is what? 1 over period, which is what? T. So if you use 1 multiplied by this, it's going to have it like this form. So that's why I leave it here. So what formula have we gotten for angular velocity? We have gotten first, second and third formula. Now going over to this next one, which looks something of this form. I will not explain it. This what we have here is known as phase angle. Phase angle, that is the phase of a wave, or phase of a wave, I mean to say, is where that wave is when you sighted it, but that's not what we're talking about. We're talking about the formula here. Now phase angle is equals to kx. All right, whereby the k we have here, is equals to what we know as 2 pi. It equals to 2 pi over lambda. So substituting that value for k, we are going to have our expression to look like this. This is furthermore going to be equals to 2 pi, which is for k, over lambda, and we attach the what? The s value. So have you seen? All right, so this is it. I have the angular velocity to be in this form. These are the formula: first formula, second formula, and third formula. And the phase angle have just two formula. So look at, we are going to say solution, so that y is equals to a sine bracket wt equals, wt minus. Now this phase angle, we're going to take it as ks. Taking phase angle as ks, this becomes our equation 1, whereby we substitute phase angle equals ks. This is equation of wave motion number 1. Now the second equation of motion is going to be y equals a sine bracket. Now this w we are seeing here is also equals to 2 pi f. So replacing w with 2 pi f, we know that t is already attached to it, and then we minus with phase angle, which is also equals to 2 pi over lambda. So we use this, and then we are going to use this the second time. So here we're going to have it as what? Phase angle is equals to pi s over lambda. Phase angle is equal to 2 pi s over lambda. You close the bracket. Now if you look very well, you find out that there is something common in between these two expressions we have in the bracket. What is common? You find out that 2 pi and 2 pi is common. What we're going to do is we're going to factorize it out, so that we're going to have that y is now furthermore equals to a sine. I'm going to factorize 2 pi out to have what is remaining in the bracket to be ft minus x over lambda. This is the formula I call equation of motion of wave motion number 2. All right, now we're going over to the third one. In this third one, we're going to say that y is equals to a sine bracket. Now w, I have used 2 pi f for it. In this third one, I'm going to use 2 pi v over lambda. All right, so I'm using phase angular velocity as 2 pi v over lambda, and I know that t is attached to it, and this is going to minus angular phase angle, which is 2 pi s over lambda. 2 pi f, 2 pi s over lambda. So this angular phase angle is going to be remaining 2 pi s over lambda. After we have used it on the second one, we are still going to use it and be going until we reach in the fourth equation of wave motion. So from here, if you look closely again in the bracket, you find that there is something common. What is common? 2 pi over lambda is common, because I have 2 pi over lambda, 2 pi over lambda. I can factorize it out. Factorizing it out, I'm going to have that y is equals to a sine 2 pi over lambda. Outside of the bracket is now going to leave me with vt in the side of the bracket minus x only. All right, because I factorized 2 pi over lambda out. So this equation now is the third equation of wave motion. Hope you understand. Now the last one, we are going to assume the angular velocity to be 2 pi over period, and then we use this other one, which is what? The phase angle. I want you to try that in your book. Pause this video for a minute. Okay, all right, let's continue. Hope you get that. Now we have that y is equals to a sine bracket. What do we have as w here? W we are now going to use as 2 pi over t, which is period. 2 pi over t minus what we have is phase angle to be what? 2 pi x over lambda. Now if you look closely very well, what are we going to see? What is common? Sorry, there is t here. What is common? What is common here is 2 pi. 2 pi, 2 pi is common. So I'm going to factorize 2 pi out. If I factorize 2 pi, I'm going to have y is equals to a sine 2 pi is going to come out of the bracket, and I'm going to have what is remaining at the bracket at t. That is this small t over big T. This is time. This is also period. All right, minus 2 pi have gone out, so what is remaining is s over lambda. Now this I have here is the fourth equation of wave motion. Hope you get something from this. All we need to do is to know the formula for angular velocity. So that brings us to the end of this video. Hope you learned something. In our next video, we're going to talk about this formula using past UTME question paper. So don't forget to click the notification bell to notify once I post this video. Don't also forget to like this video, share to your friends, and invite more friends. If you're JAMB students, we have an online class going already. You link me on the link on the comment section. Thank you, and bye bye once again.